Okay, let's unpack this because imagine meticulously planning this massive corporate network heist, right? You write the scripts, you set up the infrastructure,
Oh, yeah.
and then you accidentally leave your blueprints, your toolkits, and like your personal wallet sitting on a public counter for anyone to find.
It's the ultimate unforced error.
Right. And that is exactly the inciting incident we are looking at today. Welcome to this deep dive, where we're going through this totally fascinating stack of July 2026 cybersecurity reports you sent over. Our mission today is to sort through all this to understand how threat actors are rapidly industrializing their attacks.
Yeah, using artificial intelligence and subscription models, basically.
Exactly. And the hook here from the Lexfor report is just wild. There was this live Microsoft 365 phishing operation running out of a server in Budapest.
Right, the Budapest server.
Yeah, and the operator completely exposed their entire backend. Why? Because they ran a single sloppy Python command. Literally, Python 3, http.server 8080. I know, they left directory listing switched on, and because of that one tiny mistake, researchers were able to just, walk right in.
Walk right in and download everything.
Everything. Their .bash _ history, their credentials, custom toolkits, even their Telegram session files. It's crazy.
It really is. And, the irony of an attacker getting breached through basic misconfiguration is always deeply satisfying.
Oh, totally.
But what researchers actually found inside that server is, well, it's much more important than just a single threat actor's bad operational security.
How so?
Because that open directory acted as a window into this massive interconnected supply chain. We aren't just looking at one hacker's hard drive here. We're looking at the back-end infrastructure of a rapidly industrializing underground economy.
Which completely shatters that Hollywood myth, right? The lone genius hacker writing custom 0 days in a dark room.
Yeah, that guy doesn't really exist anymore, or at least he's not the main threat.
Exactly. The tools sitting on that server, many of them belonging to an operator tracked as Codemato, by the way, they point to a landscape where hacking is no longer a bespoke skill. It's a packaged mass market service.
Using his custom Medu Blaster bulk mailer.
Yes, the Modu Blaster. And looking across your sources, from ZeroBakey, Socradar, and Lexfo, the unifying theme is the explosion of phishing as a service, or FACE.
What's fascinating here is how the ecosystem has evolved into a highly structured industry. I mean, the ZeroBakey report highlights this platform called Ford 365, which operates entirely through Telegram.
Just right there on Telegram.
Yeah, it isn't some dark web secret you have to hunt for. It's a commercial product. It's available for $400 a month or a discounted $3,800 for an annual plan.
Wait, they have subscription tiers and automated renewals?
Yep. Annual discounts, the whole 9 yards.
Are we talking about a literal B2B software company for cybercrime? It's like Shopify or Salesforce, but for, evil, for launching network intrusions.
That is exactly what it is. And for that price, the buyer gets a completely mature operator workflow. The feature list in that ZeroBAC report reads exactly like a legitimate marketing software brochure.
Right. They provide AI-generated email lures and automated SMTP rotation, which basically means the software automatically cycles through different outgoing email servers.
Yeah, so the attacker's domain doesn't get blacklisted.
Wow. They even offer API integration with legitimate delivery infrastructure, like Amazon SES and SendGrid.
Which is key, because the attackers are leveraging the exact same delivery mechanisms that legitimate corporate marketing departments use.
So that's why these phishing emails are so easily bypassing traditional spam filters.
Precisely. But the real value proposition of a kit like Ford 365 is how it handles post-exploitation. The report details this Chromium browser extension they provide called ForCookie.
Oh, right, ForCookie.
Yeah, and this add-on automates the most tedious part of session hijacking. So once an attacker steals a Microsoft session cookie, ForCookie silently acts as an intermediary. It injects refresh tokens and triggers silent OAuth flows.
Okay, let's break down that silent OAuth flow for a second, because that's a really critical mechanism for you listening to understand. Usually when an app needs permission to access your Microsoft data, you see a prompt asking you to authorize it, right?
Right, the little pop-up window.
Yeah, but this extension is essentially working in the background. It communicates directly with Microsoft's authorization servers using the stolen cookie and constantly requests fresh access tokens. And it does this without ever triggering a prompt on the user screen.
Exactly. It keeps the attacker's access alive indefinitely.
All while the victim has absolutely no idea.
And that automation deliberately lowers the skill threshold. A threat actor with almost zero technical understanding of Otho or session management can just purchase Ford 365.
Or a competing kit, right?
Right, like The Quarry, which is run by an actor named Rocky Belling. That one cost anywhere between $500 and $3,000, according to the Sakurara report.
Wow.
And you just instantly start orchestrating complex campaigns. They have graphical user interfaces, dedicated customer support.
Customer support for hackers.
Literally, yes. And automated persistence. The technical heavy lifting has been entirely abstracted away from the person actually launching the attack.
But okay, if the people buying these kits are essentially low-skill point-and-click operators, it raises a really glaring question about corporate defenses.
How are they getting past MFA?
Yeah. Almost every organization today has deployed multi-factor authentication. We have passkeys, we have FIDO2 hardware tokens. It seems impossible that a low-tier operator buying a Telegram subscription could bypass that level of security.
Well, they don't bypass it. That is the genius of the modern phishing proxy, like the Black Queen Evilginx fork found on that exposed Budapest server.
The one authored by that actor, Cyrilo01, right?
Yes, Cyril01. That tool ran quietly for over a year and captured 218 corporate mailboxes. Because the developers behind these tools understand that breaking modern cryptographic authentication is mathematically unfeasible.
Right.
So they don't try to break the lock. They get the user to hand over the key. They use a technique called device code phishing.
I really want to make sure we map out exactly how that works because it fundamentally changes the nature of a phishing attack. Traditionally, you click a link, go to a fake website that looks like Microsoft, and type your password into the attacker's server.
Right, that's the old way.
But with device code phishing, the attacker isn't spoofing a login page at all, are they?
No spoofing required. The attacker abuses the legitimate Microsoft OAuth device code flow.
Which is what, exactly?
It's a sign-in path Microsoft intentionally built for devices that don't have a web browser or a keyboard. Think like a smart TV, a gaming console, or a corporate Teams room display.
Okay, makes sense.
To authenticate one of those devices, the hardware contacts Microsoft and says, I want to log in. Microsoft replies with a short alphanumeric code and says, go to microsoft.com/device login on your phone or computer and type in this code.
So the attacker just runs a script on their own machine to initiate that flow. Microsoft hands the attacker a real code, and then the attacker wraps that code in an urgent-looking email.
Yep, maybe pretending it's a mandatory authenticator app update.
Right, and sends it to the victim.
And this is where the defense totally falls apart. The email instructs the victim to go to the actual genuine Microsoft URL and enter the code.
Not a fake link, the real link.
The real one. When the victim does this, their corporate web filter checks the URL and sees it's completely safe. The victim enters the code, Microsoft prompts them for their password, and then prompts them for their multi-factor authentication.
Wow.
The victim can use their highly secure FIDO2 hardware key, and the authentication succeeds perfectly.
It's like me wanting to get into an exclusive, highly secure club, right? I don't try to forge a VIP pass. I just walk up to the perimeter, grab a blank VIP pass, and hand it to you.
Exactly.
I ask you to go to the bouncer, show your real ID, do the biometric scan, get the pass stamped, and then hand it back to me. The bouncer saw you, but I now hold the validated pass.
That analogy perfectly illustrates the concept of origin binding. Security architects rely on origin binding to ensure that the authentication token is cryptographically tied to the device that requested it.
But here, it's tied to the attacker's device.
Right. In the device code flow, the origin binding is completely clean from Microsoft's perspective. The authentication happened on genuine infrastructure. But the victim didn't authenticate their own computer. They authorized the attacker's device.
The bouncer stamped the attacker's pass, and once that MFA prompt clears, the attacker's backend system, which has been quietly polling Microsoft this whole time, is instantly granted a highly privileged session token.
Exactly. And researchers actually found a deleted Git commit on the Budapest server showing 97 live Microsoft tokens from corporate victims just sitting there.
97?
Yeah, 97 tokens set to auto-refresh within this framework.
Yeah.
Some had been kept alive through up to 25 automated refresh cycles.
Here's where it gets really interesting, though. There was this incredible bit of irony from the server logs involving another operator on that server, Mail Argenta.
Oh, Mail Argenta, this is rich.
So this guy set a ridiculous one-year time to live on his captured cookies. Exactly 31,536,000 seconds.
Wow.
Yeah, expiring June 30th, 2027. He intended to stay logged into his victims' inboxes for a full year, but he got caught because his own hard-coded MySQL password leaked in a completely separate InfoStealer log.
Right, he was running an industrial-scale operation to steal credentials, but he was reusing his own database password across his personal accounts, and someone else's malware scooped it up.
He fell for the exact same ecosystem traps he was setting for others. These masterminds are making rookie mistakes, and that exposes a critical reality. These operators are not coding these complex device code bypasses themselves.
Definitely not.
The intelligence behind the code isn't human, which brings us directly to the third major through line in your sources, the overwhelming reliance on artificial intelligence.
Yeah, the evidence of AI acting as a co-pilot or an accomplice was scattered all over that server.
Hey, what?
Well, researchers found code commits that were literally co-authored by Claude models. And that operator we just mentioned, Mail Argenta, he actually left a file called instructions.txt sitting in an open directory.
No way.
Yes, it was a verbatim transcript of his AI prompt history, detailing exactly how to build features for his proxy. And Codemato was using a paid API called CyberNarova.
Leaving your verbatim chat history with an LLM on an exposed server is just wild operational security.
But, the AI integration goes far beyond just helping low-tier criminals write phishing proxies. Much further. Look at the Huntress report in your stack. It outlines an active directory breach from early June 2026 that shows what happens when these AI-generated tools actually hit an internal network.
Right. The attacker used an AI-generated PowerShell script. And researchers knew it was AI-generated because the script's title was literally, and I quote, 100% working AD information gathering script, fully fixed.
In all caps.
In all caps. That is the most characteristic large language model output possible. It paints a picture of an attacker just arguing with a chatbot for an hour, pasting error messages, until the AI finally spits out something that works.
And barely works. At that, the Huntress researchers described the code as vibe-coded.
Vibe-coded?
Yeah, it lacked the elegance of traditional malware. It was highly aggressive, incredibly noisy, and just completely over-engineered. It featured this bizarre 5-step cascading fallback mechanism just to locate a domain controller.
Which is usually a simple task.
Exactly.
Yeah.
And almost comically, it was programmed to beautify its console outputs in cyan, green, red, and yellow text.
Because, obviously, if you're stealing corporate data, the terminal interface needs to have good aesthetics.
Naturally.
But, looking past the sloppy code, there is a much more dangerous implication here. The Signia report details a massive cloud extortion attack on an Amazon Web Services environment.
And that one was fast.
Unbelievably fast. The attacker went from initial access to completely compromising the environment in just 72 hours.
And that timeline is the critical metric. During those 72 hours, the attacker purged SQS
Which are basically the communication channels that let different parts of a cloud app talk to each other, right?
Correct. And they denied access to S3 buckets where all the actual data and backups are stored. They essentially lobotomized the cloud environment and held it for ransom.
Wow.
And the telemetry showed heavy AI assistance at every single step.
Wait, so let me challenge the narrative here for a second. We aren't talking about a sci-fi scenario where AI is inventing terrifying new zero-day weapons, right?
No, not at all.
Is the AI basically just acting as a highly caffeinated administrative assistant doing all the boring, repetitive hacking chores?
That's a great way to put it. AI is not changing what the attacks are. It is changing the speed and the scale. It allows a threat actor to take a pre-compromised RDP session and execute a smash-and-grab playbook across a complex cloud environment in hours rather than weeks.
Which brings us to the most important question for anyone listening to this deep dive. How does a normal organization actually defend against this?
That's the million-dollar question.
We have this industrialized subscription economy for cybercrime, attackers using legitimate device codes so passkeys don't matter, and AI compressing a multi-week cloud intrusion into a 72-hour window.
Sure.
What is the actionable defense playbook here?
Well, we have to address the device code phishing first. As we established, a better passkey won't save you. The solution is a policy lever called conditional access. Organizations need to go in and block device code flows entirely unless absolutely necessary.
And if an organization has legacy hardware, like a specific Teams room display that absolutely requires a device code,
You apply granular exceptions. But for your general workforce laptops, mobile phones, remote users, that authentication path must be shut off entirely.
okay, block device codes. What about hunting metrics? If a defender wants to check if this has already happened, what should they look for?
You need to check your Untra sign-in logs. The reports flag a very specific indicator of compromise. Defenders should search for the Microsoft Office Client ID 3590 D652B3 4182 EFA AFAT 2292 EB01C.
Okay, long string, but essentially you're looking for that specific client ID combined with unfamiliar source IP addresses, right?
Exactly. But there's a crucial tip from the Lexfo report here. You can't just look at the live authentication protocol because the automated tools are constantly refreshing the tokens.
Oh,
Later refreshes might hide the initial device code flow. So defenders have to dig deeper and look at the original transfer method field to find the true origin.
that's a great tip. Also, looking at the 0BX report, they mentioned that organizations have to audit their mail flow and decommission legacy aliases.
Yes, basic server hygiene is huge.
They found that one attacker got straight into an inbox simply by using an old pre-acquisition email alias that completely bypassed modern security filters.
Yeah, you have to clean up those old doors. And IT teams need to be looking out for RMM persistence tools like XEOX agents, which that Codemato operator was using.
So we have blocking device codes, auditing entry logs, and cleaning up legacy aliases. But if we connect this to the bigger picture, static rules feel a bit insufficient against AI speed.
If we connect this to the bigger picture, it's about shifting the entire philosophy to continuous access evaluation, or CAE.
Break that down for us.
So in traditional security, the perimeter is the login screen. You log in, you get a session cookie, and you're trusted until it expires. Remember our guy with the 31 million second cookie?
How can I forget?
A static defense says he's safe for a year, but continuous access evaluation is context-aware. If a token is stolen and moved to a weird IP address or the user suddenly downloads mass amounts of data, the system reevaluates the context in real time.
And just kills the session.
Exactly. It kills it and forces a brand new authentication, regardless of its lifespan.
That makes total sense. Well, we've gone on quite a journey through your sources today. We started with a single, misconfigured Python server in Budapest, which exposed the sprawling underground of AI-powered phishing as a service.
And we mapped out device cunning deception.
Yes, showing how attackers don't break cryptography, they just trick the victim into doing the origin minding for them. But the core takeaway for you, the listener, is that while cybercrime is automated and accessible now, the defensive levers remain entirely within your control. Conditional access, continuous evaluation, basic hygiene.
It's all stuff you can implement today.
Exactly. So what does this all mean? I want to leave you with a final thought to mull over. If AI is now successfully writing the malware, generating the convincing email lures, and automating the cookie theft.
It's doing the heavy lifting.
Yeah. So how long until organizations have to deploy defensive AI just to mathematically prove to the system that the person logging in is actually a human? Are we heading toward a closed loop of AI versus AI authentication where human input is entirely obsolete?
It's a sobering thought, for sure. The machines fighting the machines.
It really is. Well, thank you for sending over such an incredible stack of research, and thank you all for joining us on this deep dive. Stay safe out there, audit those conditional access policies, and for heaven's sake, if you're spinning up a server, do not leave the directory listing switched on. We'll catch you next time.